This is a lesson over the universe, step 2. We are going to focus on the positions and motions of the Earth, Sun, and Moon. We'll start off with the learning targets. The first learning target is that you can illustrate or model the Sun, Earth, Moon system. To illustrate or model, you need to do some sort of diagram. So you might draw the position of the Sun, Earth, and Moon relative to each other. You might draw the distance relative to each other. Or you might create a model out of clay or other materials. The second learning target is that you can differentiate between rotation and revolution. In order to differentiate, you need to tell the difference between two different things. Rotation and revolution are both movements or actions, so you need to be able to tell the difference between the two. The third learning target is that you can illustrate or model the tilt of the Earth. So again, an illustration or a model is some sort of drawing or thing made out of other materials. And we're looking specifically at how the Earth is tilted on its axis. The fourth learning target is that you can explain the cause of day, night, and years. So in order to explain something, you might have to describe it, give some details, tell about it. And we want to look at what causes, so what sort of positions and motions between the Sun, Earth, and Moon cause day, and what causes night. What sort of motions cause a year to happen? And again, this is going to focus on the second learning target, which is the rotation and the revolution. The final learning target is that you can explain what causes the seasons. This learning target ties in directly with the second, so looking at, again, rotations and revolutions, and also looking at the tilt of the Earth. Let's get started. Sun, Earth, Moon. So here are a couple of images to represent the Sun, the Earth, and the Moon. You might already know this, so this should be a review. The Sun is the largest object in our solar system, and it's the largest object between the Sun, Earth, and Moon. The Earth is the next smallest, but it's still much, much smaller than the Sun. You can see that by the top image. The Sun is huge relative to the Earth. The smallest object between the three of these is the Moon. The Earth is further away from the Sun than the Moon is from the Earth. So there's a huge distance between the Sun and the Earth, and then the distance between the Earth and the Moon is a little bit smaller, or quite a bit smaller, actually. The distance between the Moon and the Sun is far, but it also depends on where the Moon is in orbit around the Earth. So sometimes the Moon is closer to the Sun, and sometimes it's further from the Sun, depending on its orbit. The Earth revolves around the Sun, and the Moon revolves around the Earth. And we're going to get into revolution versus rotation in just a minute. But revolving means circling around. So the Moon is constantly circling around the Earth, and at the same time the Earth is constantly circling around the Sun. It's the Sun, Earth, and Moon. So the second learning target was to differentiate between rotation and revolution. Here we go. Rotation is when something spins on an imaginary axis. And so a real good example is a top. So a top spins, just spins in place. A revolution is when something orbits or circles around another object. So just like I mentioned in the Sun, Earth, Moon system, the Earth is constantly circling around the Sun. The Earth is both rotating and revolving. So the Earth is constantly rotating on its axis and revolving around the Sun. Let's talk a little bit about what causes days and nights. So days and nights are both caused by the Earth rotating or spinning on its axis. When the Western Hemisphere, which is the hemisphere that we live on, is facing the Sun, then we have day. So the sunlight and where we are in our rotation is what causes day. When the eastern hemisphere is facing the sun, so this is the hemisphere that's opposite ours, this is the hemisphere that most of Europe is on, then they're having day. And when the eastern hemisphere is facing the sun, we're having night. So we are faced or rotated away from the sun. So the other side of the earth is shadowing the sun from us. When the western hemisphere, which is again the hemisphere that we're living on, is facing the sun, then the eastern hemisphere is having night. So our rotation on our imaginary axis is what causes day and night. What causes a year? So a year is caused by the Earth revolving. So the Earth's making one complete circle around the sun. That equals 1 year and approximately 365 days. Seasons. We're going to do a really brief lesson on seasons, and then I want you to go on the website because there is a link to Khan Academy, which is about a 20-minute lesson, but he does a great job explaining what causes seasons. So we'll just start off by what does not cause seasons. Seasons are not caused by the distance between the Earth and the sun. So the Earth is not getting closer or further from the sun, causing seasons. The Earth is always a certain distance from the sun. But seasons are caused by the angle in which the sun rays hit the Earth. And this is caused by our tilted axis. So the Earth has an imaginary line through the middle of it from North Pole to South Pole. And the Earth does not stay in a straight up and down line. It tilts a little bit, 23 degrees. And because it tilts, then the sun rays hit the surface at different angles, and this is what causes the different seasons. It's important to know that seasons do not exist in all parts of our world, and in fact they do not exist at the equator. The sun rays hit the Earth's surface at a 90-degree angle at all times. And this doesn't cause really, really hot weather or really, really cold weather, it just causes mild weather. So at the equator, it is always about 70, 75, 80 degrees. So it's just always a comfortable temperature. And like I mentioned before, you can learn a lot more about seasons from Khan Academy. Please check out my website. Thank you.